frame. So here, whenever you are doing frame, so once again it requires to add some information. Okay, whatever the data it receives from the upper layer, it should be divided into a set of frames. Okay, so when you want to transmit these frames, so along with this data in the frame, even it requires to add the source and destination address. Okay, it should add the source and destination address, and also it requires to add some extra information. Okay, because it has to differentiate depending on the type of framing. Is it a fixed framing or variable framing? I think I've already told two types. That is, fixed framing means it does not require any delimiter. That means if this is frame 1 and this is 2 and this is 3, to differentiate frame 2 from 1, okay, so we need some mechanism. So like how you are writing letter, okay, 4 members you can write a letter. So you're not directly putting that letter into the box, post box. You will just wrap that into an envelope, okay, you will add address, then you will put that letter into the post box. The same thing happens here. When the frame is formed, so here it requires some mechanism to differentiate frame 1 from the other frames. Okay, so that is one method is fixed framing, fixed size. So in this case, it is not having any problem because we know that the size of the frame it is fixed. So once it is started transmitting, so once the if it is 2 byte information, okay, that indicates that is the end of the frame. Okay, next whatever the data is coming, it is indicating that the second frame. So like that. So in case of fixed size, it does not require to add any boundaries or delimiters to the frame. Okay. Next we have variable size framing. So if it is variable size framing, okay, so if one frame is 1 byte and the second frame is 2 bytes and the third frame is coming with the 3 bytes. If this is the case, how the receiver will come to know that, okay, so where to end, which is the starting of the frame, which is the end of the frame. Okay, it's very difficult to know that. So for that, there are two approaches are used, okay, to differentiate each of the frame. So here two approaches are used. One is character oriented approach and another one is bit oriented approach. Okay, so let me just go to this very simple topic. Okay, don't make it complex here. So what is character oriented means, here the data to be carried are 8-bit characters. Okay, that is from coding system, that is ASCII value. So the header and trailer are also multiples of 8 bits. Okay, so you know what is the purpose of adding trailer and header here, what it indicates. So here header carries the source and destination address, and also many times I have already told data link layer, only the layer it will add the trailer information. Okay, so you just go back to OSI layer and you can just see, okay, this part is header part and this part is the trailer part and this is the data. Okay, so this trailer part header is source and destination address, and this trailer part indicates what we have discussed in the previous chapter, that is extra bits. Okay, or CRC or checksum, whatever we have calculated, no, so that extra bits or redundant bits is added at the trailer part, and that can be used for error detection and correction. Okay, so in the previous chapter we have learned the method how to calculate what extra bits should be added so that the receiver can make use of those extra bits for error detection and correction. Is it clear till here? Yes, you should keep responding. Okay, so next, to separate one frame from the next frame. So this is common for all the frames. Okay, so this is the basic information should be added to the frame. So now in additional to this, to differentiate one frame from the other frame, it requires to add some indication, that is called as the delimiters. Okay, so the end of the frame, you should add some flag information indicating end of the frame. Okay, so you need to add the flag information to the beginning of the frame to indicate that is the beginning of the frame. Okay, so here we are going to add a flag. Okay, flag is nothing but it is particular the predefined pattern. Okay, predefined pattern of zeros and ones. So flag is composed of protocol dependent special character. It is having some special characters. Okay, it will be having some special characters. So like example, I will show you, maybe I have a diagram next. So if this is my flag pattern, okay, so this is not only zeros and ones, it can have some other special characters also. So that can be formed as a flag, and this information should be added to the beginning and end of the frame. So this is indicating the beginning of the frame, and this is indicating the end of the frame. Okay, you can just observe. Okay, this is an example of character oriented protocol, or sometimes in the exam they will ask it as a byte oriented protocol. Okay, we have two types, byte oriented and bit oriented. Because why it is called byte oriented means you are going to add one extra byte. I will tell you that later. So this is how the frame is formed. It is just single frame. Okay, it is of size that is variable in length. Okay, it is variable in length. It is not fixed. You can just see there is a header and trailer information, and this is a flag. So to indicate beginning and end of the frame. So like this, it is going to add, the data link is going to add this information for all the frames. Okay, that is whatever the data that is receiving from the upper layer, that is network layer. So that is considered here, plus additional information is added. Okay. So in case of here, what is the problem arises here? The character oriented framing is suitable only when text is exchanged by the data link layer. Okay. So most of the time, if it is only text, so this method, whatever I have shown here in this diagram, adding the flag and sending the frame. So this is works fine for the text. Sometimes if the information is like of type, audio, video, graphs, okay, some other type of information, in such cases what happens? Just think, okay, what happens here is the pattern, whatever you used for flag, okay, whatever you used for flag, the data, okay, that data may be part of pattern may be part of data. In that case, what happens? Whenever if the receiver is started reading the frame, okay, from your, consider this flag may be pattern of this data. So consider the pattern is arrived here. So what the receiver will think that, oh, this is the end of the frame, okay, then stop reading. Okay, so that is the problem arises when you're going with the different types of data. There may be possibility of this flag pattern, whatever you used, it may be part of data. In that case, the receiver is going to think that this is the end of the frame, okay, and it will stop further reading. Okay, so that is a problem occurs. Now, if that is a problem, say I'll be going little bit just fast. If you get any questions, you just interrupt me. So if you're getting that problem, then what is the solution for this? What is the solution? In case if flag pattern, if it is a part of data section, so the receiver is going to wrongly end the reading of the frame. So now solution is go for byte stuffing. Okay. In the exam, so either they may ask character oriented framing method explain, or they may ask byte oriented or byte stuffing. Okay, so all these terms will be using interchangeably. You just be aware of it. So here byte stuffing or character stuffing. So why it is called byte stuffing means whenever if the pattern, okay, whenever if the pattern used for flag, if it is part of data, so in that case you are going to indicate that that is not the end of the data, it is a pattern. Okay, that is the part of data. This pattern is not end of the frame. To indicate that you are going to stuff some extra byte information in this part. Okay, so that the receiver will predict, I mean will extract the data correctly. Okay, so byte stuffing. So here what is the extra byte is added, that is important. Okay, whenever the pattern is going to the flag pattern, if it is repeating in the data, okay, it has to use the stuffing method. Okay, the sender is going to do all this. The data section is stuffed with extra byte. Okay, that is the reason why it is called byte stuffing. So this byte may be called as escape character. Okay, so what is the character you are going to use to avoid this conflict? That is escape character. Okay, so whenever if the okay, so this is the data from the upper layer, that is network layer. You can just see in this data itself, so there is a flag already. The pattern of this flag, whatever you added, going to add now, the data link layer, that is already part of flag. Okay. So if that is the case, I will go to this part later. Just look into this. So in that case, what happens when the receiver receives, it will come to know that this is the end of the flag. Okay, that is wrongly extracted the data. To avoid that, whenever if the flag is if this pattern of data is repeating in the data, you just add this extra byte. Escape character should be added to the flag. Okay, so escape character should be added to the flag to indicate that this is not the end of the frame. Okay, so you can just see that is extra byte is added, and this is at the sender side. So how escape, this is the network layer at the sender side. Network layer is going to send the data to the data link layer, then data link layer is forming the frame. Okay, so this is all clear. Flag, why flag is added here? Okay, that is to indicate beginning and end of the frame. Okay, and this is source and destination address. This is for error control information, error detection control information. Okay, so now only I am discussing with respect to stuffing. Now once you send to the destination or the receiver, once it is received, what happens is, so the receiver is start reading the data. Okay, so once it meets with the escape character, it will come to know that whatever the data it is next is there. Okay, this is not the end of the frame, it is a part of data. Okay, so that is the reason you are adding this extra byte that is going to inform to the receiver, this is not the end of the frame, this is a part of the data, this pattern is part of data. Okay, then what the sender is going to do, so it is going to just remove this escape character, whatever the extra byte is added, and remaining data is extracted and delivered to the upper layer. Okay, so at the receiver side, it is going to deliver to the, see this is like this. You need to understand, very simple thing. If you have understood the previous methods, network layer, and this is data link layer, it is sent to the receiver. Okay, so once the frame is received at the receiver side, it will remove this escape character and the data is correctly extracted and data will be delivered to the network layer. Okay, that is one case. Another case is, consider there may be possibility whatever the extra byte you added, no escape character, that is also may be part of data. Okay, are you getting? Even this, whatever the extra byte you have used, no, there may be possibility this character also may be part of data. Okay, so in that case, what you have to do? You have to add one more escape. I think in C program, okay, if you want to display something, like there are some predefined characters, you cannot change the value of that. So in that case, what you have to use? You're going to use forward slash and you will try to display that. Okay, so similarly here, what happens to tell that this is not like indicating something like not part of flag. Okay, so to avoid that confusion, because you are adding escape no here, so it will think that the next whatever the pattern you are going to get, that is part of data. Okay, so now to avoid that, in case if escape is also part of data, to avoid that confusion, you are adding one more escape character. Okay, you can just observe here. So to indicate that this is escape is part of data. Okay, so escape, then escape. Why I am adding these two escape? This is to inform that this escape is part of data. Okay, and this is escape is added to indicate. Okay, so this flag is part of data. Okay, and whenever it is received at the receiver side, so these extra byte, whatever it is added, it is removed and only the data is delivered to the upper layer. Okay, so very easy, you can easily understand what is byte stuffing. So this diagram explains both stuffing and unstuffing. Okay, so this part is a stuffing part at the sender side and this is called as unstuffing, that is removing whatever the extra byte you have added. Okay. Okay, so next we have another method called bit oriented framing. Okay, so in this case, instead of going for byte, here we are going to discuss with respect to bit. Okay, you are going to just add one bit as a extra bit for stuffing purpose. Okay. So let me go to the diagram. Okay, it's very similar to that. So here you are going to represent bit oriented protocol. So this is flag. I told flag means it is not something else. It is having some standard pattern. Okay. So this is a flag. What it contains? It contains 0 followed by how many ones? 6 ones. Okay. Then header, then followed by data, trailer and flag. So now in case of bit oriented protocol, what happens? Okay, here I am just representing the data in terms of bits. So here there is a possibility that this whatever the pattern you are specified here, okay, it may be part of data. In that case, how we are going to use bit oriented protocol? Okay, I am not going to stuff complete one byte. I am going to stuff with a single bit. That's why it is called as bit oriented protocol. You can just observe carefully. So what is the condition? So I know that what is the data pattern? It is 0 followed by, sorry, 0 followed by 6 ones, 2, okay, and 0. So in case if this pattern, whatever I have used for flag, in case if this pattern may appear as a data in the received data from the upper layer. Okay, so this pattern may be part of data. In that case also what happens? Okay, whenever if the receiver is reading that data, so 0 followed by 6 ones and 0 indicates that is the end of the flag. Okay, so whenever if that sequence is occurring, the receiver may think that it is end of the frame. Okay, to avoid that confusion, so here we are going to use the bit stuffing. Okay, so now you can just take, this is the data received. Now you can just check it here. Okay, 0, 1, 2, 3, 4, 5, 6. Okay, so now here what is the condition is 0 followed by 6 ones. Okay, 6 ones. After that, whatever may be the bit, okay, I am least bother, either 0 or 1, least bother. So whenever if I come across with this pattern, it indicates that this is the end of the flag. End of the flag. Okay, it will stop reading the flag here itself, because it is arrived with this pattern that is part of flag, but it is not actually the flag pattern, but the same pattern is repeated or it is come across in the received data. So in that case, okay, you are going to stuff one bit, okay, not more than that, one bit. You can just observe here. So 2, 3, 4. Okay, so that is after fifth bit, 0, 1, 2, 3, 4, 5. After 0, 5 ones, you are going to just stuff 1 0, okay, and you will write remaining data as it is. Okay, so this 0 indicates it is a bit stuffing, indicating this is not the end of the frame. Okay, this is the part of data. You continue reading. Okay, similarly you can just check it in the other sequence of data also. Here you are getting 6 ones in that case. So you have to add this extra bit as 0, okay, to avoid the confusion, to indicate to the receiver it is not the end of the frame. Okay, otherwise what happens, it will consider this is beginning of the flag. Once it starts reading the data, okay, it will come to know that this is the end of the frame and it will stop reading. Okay, so to avoid this, you are using bit stuffing. Whenever if you get this pattern, so before getting that particular pattern, you just break it by adding one extra bit, that is 0. You are adding 0 here. Okay, here also you are adding 0. So now you just, once the receiver is receiving this data, it will just remove this extra bit added here. Okay, because that agreement or that information should be known by both the sender and receiver. They will be having that exchange of information. Okay, so they will be knowing what flag they are using. All that information is exchanged through protocol, and it will remove this extra bit added here, and the remaining data whatever you are going to get, that is delivered to the upper layer. Is it clear? Is it clear what is bit oriented and byte oriented? If they ask, you should able to explain with the diagram. Okay, so what is byte oriented and this how byte stuffing and unstuffing is done. even similar to the bit oriented protocol also. Okay, it's very, very important. You may get in the exam. I mean, in the IO also. So here, yesterday I already told what is the difference between flow control and error control. Okay, so flow control means it is controlling the production. Okay, so where if you are considering producer and consumer, okay, producer and consumer, if the producer is keep on producing the item and if the consumer is not ready to receive it, okay, maybe it is slow and processing. So then there is no proper synchronization in that case. Okay, so once whatever the item it is produced, so if there is no enough buffer, then that data will be lost. Okay, so all that problem arises. That's why, so it requires some mechanism to indicate what is the speed at which the sender should send so that the receiver can receive successfully. Okay. So that is called as flow control. At the sending node, the data link layer tries to push frames towards the data link layer, okay, at the receiving node. So if the receiving node cannot process and deliver the packet to its network layer at the same rate, okay, that means with the processing. I cannot expect what is the speed of my system and what is the speed of your system. If it is working with the same speed, whatever I am delivering, you can listen and you can view at the same time. Okay, if your system is very processing is very slow, then there will be no synchronization. I am talking something and you are getting something else. Like there will be delay in accessing or getting the data. Okay, so now this is very, very important point to be remembered. So flow control is taken care by the data link layer so that it will avoid the overwhelmed receiving of the frames at the receiver side. So flow control can be feedback from receiving node to the sending node to stop or slow down pushing frames. Okay, so that's what I told. There will be protocols. So if sender is keep on sending, we should have some protocol at the receiver side to indicate that. So you slow down yourself. Okay, I am not able to process to that speed what you are producing. Okay, so little bit you slow down. So accordingly, the sender has to change its speed of sending the data. Otherwise, so there will be loss of data. So that is called as flow control. Error control I already explained in the last class. Okay, error control indicates. So in case if the received, am I audible? Just respond no. Am I audible? Okay. Okay. So if any data is corrupted, whatever the data is received at the receiver side, if it is corrupted, I told there are two possible cases. One is go with the correction. Okay. Another case is, okay, discard it. If there is a error in the received data, discard it and ask sender to resend once again. Okay. So there should be communication indicating, so whatever the data you have sent, it is corrupted. You send me once again. That communication should be there. So that is implemented using protocol. So we'll look into that protocol today. Okay, so buffer, I think everybody knows no what is buffer. Buffer is very, very important. Like it will store the data. So as soon as the data comes here, in case if the receiver is busy in processing other data, so that the data will be added into the buffer. That is a temporary memory, short memory or the small memory is given or stored at the receiver side. Okay, now whatever the data that comes, it will be added into this buffer. There may be possibility that the sender is so fast, even the buffer is already filled. Okay, now whatever the next data that comes, it will be lost. Okay, so now that problem should not occur. That's why there are set of protocols. They have the concept of flow control. Okay, so where the sender should be able to give indication to the receiver should give indication to the sender, you slow down yourself. I am not able to process to that speed. Okay, so that mechanism is called as flow control. Okay, this is the diagram you need to write. These are all basic things. Okay, you should be knowing these things. Like this is not like it is not something derive, calculate. No, once if you start learning data communication, you just immerse yourself and try to understand the basic concepts. No need to remember also. Okay, you can just, if you understand, so automatically it will be there in your mind and you can recall. Error control I already explained. Recently we have discussed now how CRC is calculated, how it is added to the data, okay, and how the sender receiver is going to make use of that extra information or redundant bit added, okay, to check received data is correct or not. Okay, here how it is done, error control. First method, if the frame is corrupted, it is discarded. Very simple. Okay, if the frame is not corrupted, the packet is delivered to the network layer. That is one case. The second method is, if frame is corrupted, it is discarded. Okay, if the frame is not corrupted, an acknowledgement is sent. Okay, obviously no, the receiver, if it is corrupted, if it come to know that if it is corrupted, it has to give an indication to the sender, you resend me this packet. Okay, how it is going to do, it has to send an acknowledgement for that. Okay, so acknowledgement packet should be sent, and that acknowledgement packet should have the sequence number of the frame which it want. Okay, acknowledgement is used for the purpose of flow and error control. Okay, you should be knowing all these terms because we'll be using these terms in the protocols. Okay, so this flow and error control, it can be achieved using acknowledgement. Okay, how flow and error control can be achieved? So normally you will be sending the sender and receiver. Okay, so if the data is lost, okay, what happens? The receiver is not received the data, and it will sender is going to wait for some time. If there is no acknowledgement received, there will be timeout time. Okay, it will keep some timeout time. If it is not received within the time, sender is going to resend the successfully. There is an acknowledgement, ACK. Okay, and also here there will be a sequence number added indicating what is the next frame the receiver is expecting. Okay, so that is how you can achieve flow and error control using acknowledgement message. What is acknowledgement? It is a very small the sized message. Okay, so the size of, if this is the size of data, and acknowledgement size, it will be having some small information. Okay, the brief information to indicate what data the sender has to send. Yeah, I think these are all the notations. It will be depicted in the diagram. I will show you that. Okay, so this is already I've explained many times what is connectionless and connection oriented. In case if anybody don't know this, these two terms, you just go back and check it. Connectionless means it is not wireless. Okay, it is not wireless. Connectionless means whenever if the node want to exchange the data, so it is not going to follow the same route. Okay, whichever the path it is available, each packet will be taking its own individual route and it will be reaching the destination. Okay, so that is called as connectionless. It is not connectionless means it is not wireless. So just remember that the term connectionless does not mean that there is no physical connection. There will be a physical connection. It indicates with respect to the logical connection, not with the physical connection. Logical connection means we have already discussed in the switching part. Okay, how connection is established, how logical connection is established, how data is transmitted. Okay, see, this subject is very interesting and this is a fundamental subject. You should know these basics. Without this, whatever you're going to learn advanced